The question says that the charge is distributed uniformly over a circular ring. The ring rotates about its axis with an angular velocity, whatever. Find the ratio of the electric field to magnetic field at a point. Okay. So now, see, the question is pretty similar to what we were trying to cover the other day. This is the ring, let's say, and this is the axis, right? Let's say this is the
Yeah.
axis. And I want to find the electric field and the magnetic field at this point. And we have derived the formula the other day, right? Tell me, what is the formula for magnetic and electric field? Electric field, we can derive it right now if you haven't already. But for magnetic field at a point, let's say at a distance of a units from the center, the radius being r, can you tell me what will be the value of the magnetic field if you remember? The other day,
Mu naught I A square, is it?
mu naught I a square, I r
By
square, not a square, r square divided by 2 और bracket में क्या हो जाएगा? It will be a square plus, since we have taken
R
capital R, so
square
it's better to keep everywhere capital R, a square plus r square to the power 3 by 2.
R 3/2. Yeah.
Whatever, this is the magnetic field. And what about the electric field? If you haven't already derived it, it's high time that we derive it. Electric field कैसे derive कर सकते हैं? At a distance a. सेम मेथड जो हमने किया था. कोई छोटा सा टुकड़ा ले लो, इसको कुछ dq बोल देते हैं, है ना? dq बोल दिया हमने. अब इस dq की वजह से उस पॉइंट पे what will be the electric field? First of all, do you agree that it will be in this particular direction because the charge is a positive charge, right? So it will be outwards in nature, right?
Yeah.
At this particular point, the field will be in this direction. Once again, if we call, let's say this angle is theta, so this angle will be theta. Basically, what we need is the electric field's vertical component, which will be cos theta, right? So
Yeah.
from this triangle, again, we can find cos theta. Cos theta is how much? It's the adjacent upon the hypotenuse. Once again, it is cos theta. I'm just writing separately. Cos theta is a upon a square plus r square. Agreed? Under root,
Yeah.
of course. This is cos theta. So if we just find the electric field due to this small charge, we can just take the vertical component. So
Yeah.
let's look at this. This distance is still this value. I was the other day I was calling this as x, let's say. And this is what we're calling as x, a by x. So this distance. So what's the formula for electric field? If you remember, the formula for electric field because of a single charge is what? Kq by r square. So can I say
Yeah.
the k dq divided by r square being x square here, right?
Yeah.
Because this is the distance, not capital R, not a, it is the value x, isn't it?
Yeah.
Cool. So we have the electric field, we have the magnetic field, and by the way, this is for a single point charge like dq. If I want to find the overall, do you agree that for each of the charges, once again the distance will be x only? It will be fixed, right? So if I
Yeah.
just integrate this, I will end up just integrating dq at the end of the day to get the total electric field. So the total electric field will be k by x square times q. That's it. But we have to take the vertical component. So this entire value will get multiplied with a divided by x. This value is x, by the way, right?
Yeah.
So that will give us the vertical component, because we already know that horizontal components, like the other day, even for the magnetic field, the horizontal components were getting cancelled. Like this was coming like this was coming like this. If you take about, remember the conical section that we talked about, the magnetic and the electric field both will be in conical in nature. So the horizontal components will kind of cancel each other out and the vertical components will get added up, right?
Yeah.
So this is the vertical component, by the way. And that's about it. We have the value of x. चलो इसको भी let's call this as x to the power 3. इसको भी हम लोग x to the power 3 बोल सकते हैं, तो कैंसिल ही हो जाएगा, इसलिए इसको भी यहाँ पे डिलीट करके x to the power 3 कह देते हैं, इस पूरी चीज़ को हटा करके, right? So
Yeah.
now can you see that if you need the what has been asked, find the ratio of electric to magnetic field. So electric is what? It's k. K is what? K is what? 1 by 4 pi epsilon naught, right? Into
Yeah.
q into a upon x cube, whole thing divided by mu naught I r square. अब निकाल लोगे ना, mu naught I r square divided by 2 x cube. So can you see that x cube completely gets cancelled? And accordingly, you can find the value. A is given, R is given, mu naught is known to me, pi is known to me, epsilon, everything is known to me, right? Q is also given. I hope x is also given, the distance दिया हुआ है क्या? हाँ, अब सवाल ये उठता है कि यार I कैसे निकालेंगे, ये तो हमने सोचा ही नहीं. यहाँ पे तो चार्ज दे रखा है सिर्फ, तो उसके लिए आपको रोटेशनल वेलोसिटी भी तो दे रखा है, द एंगुलर वेलोसिटी, राइट?
Yeah.
चार्ज कैसे निकालते हैं, मतलब करंट कैसे निकालते हैं? करंट इज टोटल चार्ज डिवाइडेड बाय टोटल टाइम,
Yeah.
right? And time, if you remember, the value of time is also 2 pi by omega. Can I not say so?
Yeah.
That's it. अगर omega मेरे हाथ में है, can I not find the time period? If I find the time period, that will give me the time. I have the charge, which is this value. I can find the time using the angular velocity. I will divide them to get the current. Because in case of magnetic field, I need the current, not just the charge. I'll substitute it here, isn't it? So tell me,
Um,
in this entire ratio, anything is not known to me. 4 pi epsilon naught is just a constant, mu naught by 2 is just a constant, r is already given to me, the distance a is also given, I hope. Of course, it's given 5 centimeter. Q is also given to me, the total charge, which is 3.14, which is basically pi into 10 raised to minus 6. So it's a good one. Pi will get cancelled in a way. This pi will get cancelled with one of the Q, isn't it?
yeah.
So that's why they have given such values. Any doubts here?
So first of all, how do you know the direction of the electric field?
Oh, since it is a positive charge always has an outward direction of electric field, isn't it? No matter, see, I had taken this particular charge. If you were supposed to find the electric field at this point, just join them and this will be the direction, isn't it? If
Yeah.
you were to find the electric field because of the same charge at this particular point, it would be outward in this direction, isn't it? So if you want to find the electric field at this particular point, which is at a distance of a units from the center, it will be along outward direction, which is this one, isn't it?
Yeah.
That's why we took the vertical component, because we understood that it's not just a single dq charge. There are infinitely many charges along the circle, right? And each of the
Yeah.
charges will have the fields, the electric fields and the magnetic field for that matter, in this conical direction. Once we have the electric and magnetic field in the conical direction, intuitively we can understand that the horizontal component of this one will get cancelled with the horizontal component of this one, isn't it? And
Yeah.
vice versa. For each of the charges, the horizontal components will get cancelled and only the vertical components will get added up. That's what we did. We just kept adding the vertical components. How did we do that? We took the component cos theta, right? We multiplied the cos theta here. See this?
Okay. Hmm.
Clear?
So one more thing.
Yeah, sure.
So omega is angular acceleration और
No, no, no.
मुझे
Omega is angular
खाली
velocity, not acceleration. Omega is angular
Oh,
velocity, right? Always has
अच्छा
been.
हाँ right angular acceleration का तो वो दूसरा symbol है. What was
Alpha.
that?
That's alpha,
Yeah, exactly.
right?
I got confused. My bad.
Any further doubts?
No.
Awesome.